CUWeatherNerd here with a briefing. It's early on Friday, April 13th. It's about 12:30 Central Time, and we're looking at the potential for a historic tornado event across the Central Plains on Saturday, April 14th. From last night's SPC Day 3 outlook, you can see a large area of moderate risk and slight risk, really painting most of the Midwest. Probabilistically note the highest possible Day 3 outlook of a 45% hatching. This is, by the way, the first time that there's been a Day 3 moderate risk since April 27th of last year, which was the Tuscaloosa, Alabama outbreak. Chasing forums have lit up with lots of forecast discussions going on right now, which is unsurprising given it being a weekend and the severity of the SPC outlook. Going through what's causing this really quickly, we're looking at the 250 millibar level here, and we can see an impressive trough with a very large jet streak sitting over the Nevada-Arizona region. You can see an impressive amount of defluence as well over the Panhandle regions into Nebraska, and also we have a series of couple jet streaks, and although we do have these interacting jet streaks, actually the effects of them are going to be somewhat diluted because we do have kind of less than favorable orientation here. Skipping forward though, as we go on in the day, we do get a little bit better looking jet dynamics where the dominant jet streaks are starting to eject out of the planes. And we can see a very, very impressive jet streak of at least about 120 knots here. Also important to note is that the center of the low is actually quite high up, and it's actually somewhat of a split pattern, and actually the wave remains largely open in this NAM. By the way, all the data being used is going to be rendered by Twister data, and we'll be using 0Z data for both the NAM and the GFS. Stepping down a little lower into the atmosphere, we're going to look at the 500 millibar relative vorticity forecasts. Starting at 18 Cs here, we can see a strong vorticity signature with our trough again, as well as a closed-off circulation at 500 millibars. We can see a small vortmax here over the high plains of Colorado, as well as an area of enhanced vorticity through South Dakota into Minnesota due to a boundary there. As we step through the day here at 21, you can see some of the vorticity starting to intensify, as well as the wave starting to take on a slightly more closed nature. Stepping down a little farther in the forecast again using the NAM and starting at 18Z, where you look at the 850 millibar dew point forecast, you can see a well-defined boundary running all the way from Texas through the Panhandle regions in Kansas, and before looping up around a circulation here right around the Nebraska Panhandle. Also notable is the wind speeds here. We do seem to have a relatively impressive low-level jet here at 18Z of about 35 knots to 40 knots. And as the day goes on, that is maintained and that boundary grows, including really quite impressive moistures of a more than 15-degree dew point across the Oklahoma into Kansas region, as well as an area of relative unseasonably moist air across Iowa and Nebraska. Looking at Theta E forecast, Theta E, if you don't know, is a way of measuring both temperature and moisture. We can see a very stark north-south oriented boundary here at 18Z through Kansas and coming up into Nebraska. And as we step through the day, we can see that boundary maintains a large amount of its identity, including very high Theta E's in Oklahoma. You can see some of the wraparound from the low here and the trough of warm air associated with it, as well as a decent amount of surface winds. This at 0Z on Sunday. So we do seem to have a strong boundary across central Kansas and Nebraska and Oklahoma. This boundary, if we look at surface temperatures, which are loading now, and by surface temperatures I apparently have them out of order, so dew points, is actually a dry line. The dry line shows a large area of 60-degree or warmer dew points extending almost to the Minnesota border, and an extremely sharp cutoff here across Kansas, Oklahoma, and even into Nebraska. This is at 18Z, and quickly stepping through the day, we see the identity that withstood, and really the notch from the low becoming very well defined across Nebraska, as well as dew points of more than 70 degrees coming up almost to Kansas City. Now looking at surface temperatures, we can see at 18Z, which would be 42 at the moment. Apparently didn't set this one up right. Oops, my apologies. I'll wait for the internet to load. At 18Z, we can see that we have a large area of warm air, but no, very strong defined cold front, at least obviously yet. We also have a surface boundary here through central Nebraska with a nice wind shift, so we can see our warm front surging north at this point. And we can see at 21 UTC that one front really continuing to surge, and that dry line really not having an associated temperature boundary all that clearly. Also note there is at least a little turning with winds along that dry line. We'll point that out a little more clearly in just a bit. Finally, just to get on that low-level jet, here are some contours or isotachs of wind speed. And we can see at night that low-level jet, as you'd expect, really becoming quite impressive, which will help these storms to remain severe well after nightfall. Looking now at some instability parameters, we're looking at the NAMS Cape. We can see a kind of a large Cape Max at 18Z across central Nebraska, with a deepening Cape Max across Oklahoma and Texas later in the day. We can see that persistent and well overnight, the Cape maintains its identity even to 9Z, which of course is 4 a.m. So we do have a large amount of surface-based instability, or max instability in this case, and that is echoed in the GFS. The GFS also shows that northern Cape target at 18Z, and continues to show the development of at least some over Oklahoma, with values peaking out around 2750. Unlike the NAM, we can see the max Cape is significantly lower later in the night. Looking at some inhibition indexes, here's the NAM, and you can see at 18Z already along our dry line, our cap is quite weak, and is expected to basically be non-existent at 21Z. The GFS actually shows the cap being relatively weakened at 18Z already, and actually through at 21. This concerns me a little bit because these high instabilities mixed with a relatively weak cap may actually mean our initiation will happen a little too early for the instabilities to actually be realized. With the convective parameterization schemes, of course, these models aren't convection allowing really. This actually may mean convection forecast and Cape forecast are significantly flawed if initiation is early, although I'm not positive it will be. Actually, I kind of think it'll be just to the opposite. Looking at EHI values for the moment, at 18Z we can see a large area of EHI across central Nebraska. And as the evening goes on, we can see those EHI values really becoming maximized over South Kansas and Oklahoma, as well as an area of enhanced helicity along the warm front here showing up. But really anywhere in this region would be showing significant severe weather EHIs. Also really quickly look at the helicity forecast, obviously only the NAM. We can see at 18Z the enhanced helicity of the warm front, as well as a broad area of favorable greater than 150 meters squared second squared helicities. And we can see that continues to be present throughout the day and really expands after nightfall with the addition of that low-level jet. So really between 21 or 4 p.m. and 7 p.m. we are looking at a very large area of extremely favorable helicity with kind of optimizing helicity down here through the Kansas-Oklahoma border, but really honestly we're looking anywhere along that dry line has favorable helicity. So anywhere a storm can be going and remain discrete, we should see very nice looking rotating storms. We're quickly looking at some model stuff here. That dry lines placement, that seems like actually I skipped something. Hold on. I did. This is Earl Barker's forecast of cap strength. So just looking at initiation stuff one more time. At 18Z, we see ongoing convection here across central Iowa, or northern Iowa and South Dakota, as well as notable weakening here along the Kansas-Nebraska border, cap of about 0. So along our dry line at 18 already, we're showing a weak cap. And that weak cap shows really absolutely no sign of holding past about 21Z. And really it does not seem to strike me as needing much proof that this cap will break, which is good news. We just want to hold long enough to get some instability really in there. We'll quickly look at two parameters here. I've plotted with something called GARP, which is an interface for GEMPAC. In red, we have dew points, so you can see our very, very tight gradient here across central Kansas and into Nebraska here, our finger of moisture being pulled up by the low. So we have our dry line through here, and I've plotted streamlines of wind, so you can see this southerly advection of very warm, moist air, 68 to 70 degree dew points even, up here through Omaha. Also like around, say, Topeka, we have extremely high dew points. And you can see there's at least some wind shift associated with the dry line, which should aid in some tornado potential. In terms of positioning this dry line, the GFS and NAM seem to be in relatively good agreement. The GFS here in blue and the NAM in green, and we can see the GFS is just a hair slower with where the dry line will be, a county or so. over the NAM. Both of these forecasts, by the way, valid at 0Z. So we'd expect storms to be a little bit prefrontal, but perhaps right through here would be a good target if you were chasing the Kansas-Nebraska border, which will be my target since I'm based over here in Omaha and don't feel like driving to Oklahoma for a storm which is going to be in my backyard as well. Looking quickly at some parameterization of how this initiation is happening, at 21Z, the nested 5-kilometer NAM run by Earl Barker does not show any composite reflectivity, although it does show initiation by 0Z. Now, looking at some of the other parameters, I don't think that's actually quite valid. I do think initiation would happen a little more or a little earlier than 0Z. That being said, we do see an area right here along the Kansas-Nebraska border, as well as a more intense thunderstorm here right at the boundary. Look at some ensemble forecasting then. We're going to use the off forecast for probability of more than 1/10 of an inch in 6 hours, and we can see probabilities up to 70% across the Kansas-Nebraska border, as well as an also area around Wichita here, stretching towards Joplin. Lower certainties of precipitation across Texas and Oklahoma. So right now the highest certainty of initiation does appear to be the Nebraska-Kansas area over Oklahoma, to me at least. I'm a little biased since I'm closer. HPC QPF at the time also seems to reflect this, although it does show a large area of more than 1/10 of an inch. So honestly, we do see that dry lines area showing up nicely. We see the intensification overnight as this merges into an MCS and starts to drop a little more rain than discrete thunderstorms would. And we can show that initiation seems pretty likely to the HPC as well. Model-wise, the GFS is much more optimistic, with 6-hour precipitation showing initiation up and down Kansas and into Oklahoma. The NAM, on the other hand, doesn't show very much. It shows initiation here in Texas and in Kansas, but nothing here, even though the nested NAM is showing things here, and also HPC and ensemble models show this is highest. So this is something that I'll be watching future runs to see if this starts to resolve itself or becomes an issue. Finally, composite reflectivity at the time, which is not something I would normally use too hard, does identify an area of at least some initiation across central Kansas. Finally, looking at 2 representative model soundings, this one taken from near Manhattan, Kansas at 21 UTC. We see a still notable small inversion here. On the other hand, if we take our LCL height, we can see that we might be eking by that already. This cap is relatively weak. Our profile here, you can see, is at least somewhat linear. Our hodograph, though, does show a nice looping structure, especially to 2 kilometers. So storm mode probably would still be discrete, although certainly this kind of linear pattern is something which has been indicative of the day. Also notable is just the steep lapse rates and the fact that there will be a large and kind of gratuitous amount of cape through here. These updrafts will be further buoyed by the dry aloft in these model soundings, which obviously dry air is more dense than moist air. So some dry and aloft while enhancing entrainment and also leading therefore to higher chances of microbursts and gust winds. Also will enhance the updraft strength. Looking up along the warm front just for kicks and giggles, we can see a very similar picture at 0Z, although our hodograph is a little more curved, at least more deeply, and so certainly that enhanced helicity along that boundary certainly is of interest. Which of course leaves us questioning, what does this mean for our forecast? Where to chase on a day with pretty much no restrictions, a day with a SPC moderate risk, all of that going on. Being from Omaha and noticing the highest certainties in ensemble forecast to myself, along with seeing some of the higher parameterized cape early in the day, leads me to think this area along the Kansas, excuse me for a moment, didn't expect that to zoom that way. We're up here in the Sandhills, Nebraska, which, while beautiful, aren't where I really want to be. My internet connection is all derpy right now. Alright, that should help it. Alright, along the Kansas-Nebraska border here. Looking through this area, we have a good network of north-south roads, and a not-so-good network, at least obviously quickly, of east-west roads. Also, there are some Indian reservations in this area, which do have pretty subpar road networks, even by Kansas standards. There's also a couple major rivers through here, including Tuttle Creek here, which can impede tracing. That being said, I like the high cape and most certainty of initiation in this region, save for the NAM's accumulated precipitation. And so that catches my eye in a way which is probably suggesting that my target will be just north of Manhattan, Kansas, perhaps Clay Center, Kansas at this time. The chasing strategy, of course, with relatively strong storm motions, which I didn't cover yet, but is sitting around here somewhere. Let's see if I can't find it. I'm not seeing them. Well, anyway, with relatively strong storm motions, will be to stay on paved roads and try to get behind any storms that can form out in front of the dry line, especially. That way we have the best chance of kind of having a storm on its own, discrete, with lots of escape routes and nice visibility. Large hail is almost a certainty with these storms, so safe chasing, especially with high motions and a large amount of chaser convergence, is going to be something that needs to be stressed. Good chasing ethics, of course, with reporting and also with stopping of damage, are going to be stressed as well. These tornadoes are going to have the potential to be quite strong, and so that's just something to be mindful of. All that aside, I'm not sold that the dry line through Kansas is the best bet for me here in Omaha, at least. The warm front to my north catches my attention as well. That region I know a little better from the road standpoints, and actually will have a more certain initiation. That being said, I like the idea of chasing a dry line. It's something that I don't have the opportunity to do in Nebraska or Kansas in April very frequently. And the idea of the higher amounts of instability there, even with not as strong a felicity as would be along the front, still entices me to think this area is probably the better target for seeing tornadoes. Also, this is the area highlighted currently by the SPC's moderate risk, and I do expect that moderate risk to become a high risk here relatively quickly. If not on day 2, then day 1. And of course, all this forecast is subject to change and shouldn't be used except as an educational purpose. If you are making your own forecast to chase, make sure to look at your own data, because I'm just a college student and therefore probably not someone you want to listen to for deciding where you want to put your vehicle and your car in situations of very, very strong weather like this would be. With that, look for updates, and this is CUWeatherNerd signing out.